Hello, this is Jason Gleckner, the iCOM Product Manager. This short 5 to 6 minute video will take you through some of the basics of the iCOM Smart Aisle and some of the reasons why we've developed the control strategy that we did. I'm sure many of you have seen this graphic before on the energy savings based on the fan motor cube law. These savings have driven the popularity of our VFD and EC fan option. However, there needs to be a balance between lowering fan speed for energy savings and making sure there is enough airflow to sustain the equipment. So doing this without compromise. With the Liebert Smart Aisle control, we can provide the end user this balance. Let me show you the extremes of airflow management in the data center before jumping into the Smart Aisle control description. When we look at the control strategy with fixed fan speed, the only energy savings to be had was to place a unit into standby mode. In this example, we yield a 8.1 kilowatt-hour savings in the application on the left. With variable fan speed and the cube law benefit that these motors provide, keeping all units on and ramping the units in unison would provide even greater energy savings, shown at the 13.72 kilowatt per hour. In addition to the greater energy savings, the underfloor air distribution would be more consistent with the control strategy on the right. When a unit is placed into standby, as shown on the left, and the fan is deactivated, it creates a void under the floor that the other units will need to compensate for. Depending on the room and unit position, this could create a hot spot in the data center. Add in rotation and you have a real headache on your. This image shows a typical application where the cooling unit is supplying more airflow than the IT equipment actually requires. When too much air is supplied, two negative actions are taking place. The first is a waste of energy by the fan motor in the cooling unit, and the second is that due to the mixing of the supply and return air, we are actually decreasing the efficiency of the cooling unit. This image is showing another type of problem that could cost the end user just as much money as the previous. When we do not supply enough airflow for the IT equipment, server fans can begin to speed up. This continues to drive the demand for more airflow, which would more than likely be pulled from the hot aisle, shown as recirculation in this image. This escalation of temperature being pulled into the server will eventually cause a thermal shutdown of the IT equipment. So how can you avoid the previous two scenarios and supply the correct amount of airflow based on the IT equipment needs? The answer is simple. Control the speed of the fans, which is our method of delivering cool air, as close to the source as possible with remote rack sensors. The remote rack sensors monitor the temperature to the inlet of the racks and adjust the unit's airflow dynamically based on your cold aisle set point. So now that we are controlling at the source of our changing variable, we can change the application environment knowing that the cooling units will adjust to make sure your IT equipment airflow is met. If you decide to add containment, which provides better separation from the supply and return air streams, the fan speed of the cooling unit will automatically slow down because you have added a device that helps to direct the airflow where it needs to be. Another example is if you change the placement or quantity of your perf tiles, the cooling units will still vary the speed of the fans to make sure the airflow gets to the IT equipment. So this takes care of the airflow portion of the Smart Aisle control. But you may ask, what about the management of heat load? So this question can be solved by controlling to the discharge air temperature of the unit. By controlling to the discharge air temperature, we can be sure that the temperature being sent to the cold aisle is consistent and unaffected by the room or the return air temperature of the unit, as the compressor or chill water valve will modulate based on the load brought back to each unit and will maintain a consistent supply air temperature. So I've described the primary control of the Liebert iCOM Smart Aisle, but there are many other features that make the iCOM control efficient, reliable, and sustainable in a variety of applications. For further information on these features, see the iCOM documentation on AMP. Since there is normally more than one cooling unit in a data center, we went one step further and created a new teamwork mode called Teamwork Mode 3. This teamwork mode is unique in that it controls all of the operating units' fan speed in parallel. This creates an even underfloor air distribution and provides the best energy efficiency like we talked about a while ago in this video. However, this still allows the compressor capacity or chill water valve to modulate at each individual unit based on the discharge air temperature. So in addition to separating the airflow and heat rejection to match the IT equipment, This new teamwork mode also manages the remote sensor network between units, which can be changed based on your specific application. This is accomplished by allowing each unit to monitor the whole remote sensor network while only using a specific number of the hottest sensors for control.